Hi together. I welcome everyone in today's webinar, again hosted by the Open Telecom Cloud community. Today we have again two guests here. One is Victor, the other one is Alex. Both are from the IITS Consulting. With this, I will lead over to you, Victor.
The topic today is which cloud native technologies do I need for my OTC project? But it's also in a more general way, what do I need for my cloud native project? The presenter will be me. So I'm Victor Getz, CTO and founder at ETS Consulting. I think most of you guys know me already. And today I brought with me Alex. And yeah, he can introduce himself.
Hi guys, I'm Alex, working for IITS since the beginning of August, and we're doing awesome stuff with clouds, with Kubernetes Terraform. So I'm really happy to share my experience with you today.
Yeah, just short notice. Alex is like my mentor. He comes previously from Real Digital, now it's Scotland, and he will take over the head of infrastructure and operation in our company. And yeah, what does our company do? So we are standing for innovation as a team. I founded ETS 2019, and now 2 years later, we have already over 40 employees. And our main goal is to provide agile cloud native development teams and help business to automate the complex processes. So basically, if you want to move to the cloud, if you have some project on the cloud, then we are the right persons for you. We deliver you people and knowledge from our previous project. The more complex it gets, the better we are suited for that. So we're doing a lot of stuff on the OTC and growing and doing some awesome work. This, for example, I have 4 guys of my company. It was during a hackathon we made this picture. So what do we have today on the agenda? Today we want not to make some very technical stuff. We will not show you some development stuff where we together develop some things. Today is more like overview. We want to give you some insights from our how we do microservices, what kind of technologies we use for our cloud native parts. And so basically, if you're starting in the cloud, or if you say, I am a little bit stuck at some of the problems which I'm currently having, maybe today during the presentation, you will find some new technologies and you learn how to use them. So the main topic is today, why Kubernetes, why this hype about Kubernetes, and what is GitOps, and these both topics Alex will do with you. And the last two are, what do I need for my cloud native microservices? There we go through all the stack, what we need from our cloud native microservice. And also things to keep an eye on. So what kinds of technologies are currently hyped, and what kind of problems do they solve? And with that, I will give over to Alex. He will now share his slides, and we'll begin with Kubernetes.
Hi again. Let me please share with you our thoughts about why Kubernetes is a big thing at the moment and what exactly is GitOps in a way how we understand it in the company. And to do this, let me please jump a little bit back to the past. There was a typical situation in the companies which are doing software development. There were teams of developers and team of operation guys, and both of them were great. The issue, however, was that they were talking slightly different languages. So that when you're a developer, you're mostly talking about your code, your source code, your dependencies. You need some config files, you need some file permissions to run your application on production. Meanwhile, for operations guys, it was mostly about like what kind of software should be installed, how to secure, how to protect the production, which parts should be opened, how to deploy it properly without downtime, and how to stay secure in terms of how to store secrets and credentials. And basically, one of the reasons why DevOps as a culture started emerging is that because there was some kind of misunderstanding between these two teams. And then at some point, Docker came, and Docker was a great tool, or it still is a great tool, that solved quite a lot of communication issues in between developers and operations guys. So basically, if both of them agree on using Docker, then they should already they could already share some things that, so basically for developers it was super clear that they just need to build something somehow. They need somehow to build a Docker image, and that's it. And it will contain everything they need. And for operation guys, basically they take this Docker image and then they still somehow, but they deploy it to production, and they don't need to hassle about dependencies and so on. However, Docker was already a great step forward. However, it did not solve all the issues in communication between these two teams. And that's why Kubernetes is a big thing, because basically Kubernetes is the next big step, which took the best things from the Docker, but also it proposed a way of solving communication issues between developers and operations guys. So basically, in ITS company, we believe that nowadays Kubernetes is simply our DevOps language. And so if you want to have a good and fast software development team, you should just use Kubernetes everywhere. It's a de facto like a standard in the industry. The good thing about Kubernetes is that it is a declarative system, which means that you never write how to implement things. Instead, you just write what you want to have. And in terms of Kubernetes, this means that you have a bunch of different Kubernetes objects, and the job is to describe them. And basically, Kubernetes it covers pretty much everything that you need, almost everything that you need when you're doing software development. And that's why there is a fancy term, infrastructure as a code, which appeared before Kubernetes. However, there were no proper tooling to implement infrastructure as a code the right way, because every time there were some things that were not covered by existing tools. And Kubernetes apparently is the first tool which allows you to really make your infrastructure as a code. And as soon as you move your infrastructure in the code, as soon as you work with your infrastructure as it was just a code, you can consider your infrastructure to be also some kind of application, like a piece of software. But in case you have a piece of software, you can also switch to the best practices that developers use for developing a software, such as, for example, using Git. So instead of running your commands against your servers, against your clusters, you simply can use Git, and then magic will happen afterwards. And this is basically how people figure it out, how they came to the idea of GitOps. First, it was introduced by a company, vWorks, back in 2017. And GitOps is a way to do continuous delivery and operate Kubernetes via Git. So it means that if you want to add something to your cluster, if you want to change something in your cluster, you are not changing the cluster directly. Instead, you write your changes in Git, and then it somehow magically gets deployed to against your cluster. This also means that the Git repository becomes the source of truth. And it means that everything that is in the Git repo must be in the cluster, and vice versa, nothing in the cluster which is not in the Git repo. GitOps is a way to do continuous delivery and operate Kubernetes via Git pull requests, including code review. So as I said before, since infrastructure became just a software application, you can have a normal workflow that your developers are using. So they are opening up pull requests, you have coding review, you can also add your pipelines, which will do some linting, some checks, some tests, and so on and so forth. And also GitOps empowers developers to do operations because basically working with Git brings less stress than working with production systems. In order to have a GitOps nowadays, you need to slightly modify your CI/CD pipeline. So before it was all in one. So it started from for example, you're pushing a new commit to your main branch, or you're merging your pull request to the main branch. And then at the end of the pipeline, your code is being deployed to, let's say, production. In case of GitOps, to do it easily nowadays, you need to split CI/CD pipeline up into two different parts. So the CI part will be still be responsible for building images, for making sure that basically they work by executing tests, by linting, etc. And also its final job is just to publish images to the registry. Here, I should mention that it's not necessarily must be Docker images. It can be Docker images, it can be new Helm charts, it can be some packages if you like, whatever. It should be some kind of artifact that is the result of the CI part of the job. And then CD part basically works the following way. It periodically checks for updates from the CI part. So they agree on some registry, for example, or some storage where CI will push new stuff and from which CD part will pull new stuff. And as soon as there are changes, then CD part knows how to properly prepare these changes to your cluster, to your production. And basically at the end of the day, it does kubectl apply in some fancy way, maybe by means of Helm, maybe by means of customize, it doesn't really matter. And the selling point here is that Kubernetes will be the guy who basically will do all the heavy jobs. Because as I said before, in Git, you have only representation of the desired state. So you don't need to write down how exactly to achieve it. And Kubernetes will take this part and do everything for you. What kind of benefits does GitOps bring to the companies? First, increased productivity. Which means that teams, since everything is automated, teams can deploy frequently, and basically everything that they are working on will be visible on production faster. The second is knowledge of Git is enough for development teams to deliver value, which means that basically Git becomes the only technology you need to use to have. You don't need to write your own fancy deploy scripts in Bash or in, I don't know, Capistrano or any of them. You just use Git for it. The next thing is consistency and standardization, which means that it's a nice approach that if all the teams are sharing it, then it will be super easy for people to switch from one team to another because there will be no reinvention of wheels, and basically people can be more productive. Everything is described in the written form and can be audited in any time, which is also a good feature of Git, because then it's not possible to run your favorite command against kubectl, against Kubernetes cluster and go home. Instead, everything that ever happened with the cluster has its record in Git repo. And as we said before, everybody can work with Git, so everybody can see who exactly did it, why, and for what reason. And the last but not least, more confident that everything works fine due to reproducibility, since again, it's Git and everything is scripted. It's super easy to make your rollouts, to make your deploys before production to some pre-production stages, to some staging, whatever you call them. Since if you have Kubernetes cluster everywhere, I mean, you have one cluster for production, another cluster for pre-production, then for GitOps, it doesn't really matter against which cluster to work. All the way will be the same. So basically, as more you deploy, the more confidence you have that it basically works. It's something, if you are afraid of something, you need just to do it more often, and then you will get your confidence will come. All right. However, GitOps is not it's not a piece of cake as well. It's not a free lunch. It brings a few of issues that I would like to mention here. And the first one is injecting secrets. The problem here is that anyway, your production application needs some secrets, some passwords from the database, some passwords from the third-party APIs, whatever. And putting everything in Git is cool, but putting sensitive information in Git maybe not so cool. And you need somehow to solve this problem. And from our experience, people usually go for one of these 4 solutions. So the first one is just keep it in plain text in the source code. This is this is obviously not the good thing, but if you are just a startup and you just want to be fast, or you are a company of like 3 people, then it can be still an option for you for some short time. The second option is to encrypt your secrets, but still store them in the source code. In this case, you need to have some super secret that everybody will know, but this super secret is not in Git, and it's used to encrypt and decrypt stuff which is in Git repo. So basically, when you add a new secret, you encrypt it with your super secret, and then you pass this super secret to the GitOps application, and it can decrypt the secret. The third approach is don't keep secrets in the source code, but manage them manually in the cluster. This is some kind of moving out from the pure GitOps solution, because in this case, you explicitly say that our GitOps will manage everything but secrets. Because for secrets, we have, for example, a responsible team, and only these people, they have access to secrets, and only these people will add them manually, and so on and so forth. And the first approach is to use some third-party dedicated solution, such as HashiCorp Vault, LastPass, maybe 1Password as well. These solutions basically are designed in a way that people can create secrets in this software. And your GitOps tool, for example, it has only read access there. So when you deploy something, you put a secret in this software, then you push your code, and then your GitOps will pull your Docker image, pull your a new secret from this tool, connect them together, and yeah, then you have everything. In Kubernetes cluster, you have everything. The second issue is the state of cluster. The issue here is basically each pipeline takes time, and CD pipeline, it also will need time to finish. And when you do kubectl apply command, Kubernetes responds you very fast, like, okay, response code is 0, so everything is fine. However, it doesn't mean that all the jobs have been accomplished. Instead, it means that Kubernetes acknowledged that you want to update something, and it's going to start basically doing the heavy things. And in general case, there is no guarantee that everything will go smoothly, and at the end of the day, your desired state will be the same as the actual state. And even if it happens at the end of the day, during some period of time, you will be a little bit confused, because still your Kubernetes cluster will be in the old state. However, according to your Git, you should be already in the new state. And in case if it takes some minutes during this time, people can be confused. However, I must say that there are tools which are doing some kind of monitoring of these issues. And also from our experience, rollbacks is another thing that you should think in advance when you go for GitOps, because if you use a pure GitOps, all the changes to your infrastructure are pull requests. And so if you want to change anything, you need to create a new pull request, you need to push your code, you need to merge it, then CI part will build a new image, then CD part will somehow deploy this image, and this takes time. Imagine a situation when, this never happens, of course, but sometimes it's Friday, and you decided to deploy some new small thing to production, and then your production simply is down, your website doesn't work, for example, and business is losing money at the moment. And in this case, if you go for this long circle with the merge, with the git push, merge, and so on and so forth, this will take, let's say, minutes. However, you don't want your business to be losing money during all these minutes. And what you would like to have, you would like to have a big red button, like a rollback now, please, without asking any further questions. And this is also something that usually is against the pure GitOps. However, on practice, you want to have it. And I must say that tools that are doing GitOps, they usually provide this possibility. And the issue number 3, I think it's full automation. There is a famous citation: in theory and practice are the same. In practice, they are not. So basically, all these GitOps tools, they look very fancy, and if you read their documentation, everything is great, everything fulfills your needs. However, sometimes something goes wrong, and these tools are also written by humans. Humans all make mistakes. You should be prepared for this, and sometimes things will be just simply awkward. And so it also, since GitOps brings some kind of another level of complexity, your whole system becomes a little bit less transparent for people. In our company, we have experience with 2 different tools, which are doing GitOps. They are ArgoCD and FluxCD. These tools have, companies behind these tools, they have some complex relationships, frankly speaking. So they started as a separated projects, then they decided to work together, then they split again. And so, at least for now, for the September 2021, these projects are different projects. I don't know what will happen tomorrow. ArgoCD works in a way that you should install it in the same cluster where your application is running. Also, it can use a dedicated cluster. However, it needs its own namespace just to have a clear separation between it and everything else. To install it, it provides a Helm chart, or you can also use some bash script just to install it. Here, I must say that you have some problem of chicken and the egg, because you want to do GitOps, which means that you do not manage your cluster manually. However, in order to start doing GitOps, you need to install a tool which will be doing GitOps. And so that's why you need the very, very first command, you need to run manually. ArgoCD operates with custom resources, so it registers custom resources, application, and project, and then you need to use these objects in order to describe your application. So basically, imagine that you had your services, your deployments, your pods, everything like this, your secrets. You need then to combine them inside the application and then tell Argo, all right, this is my application, do your job. One of the advantages of ArgoCD that it has a web UI where you can take an overview of what's going on in the cluster, and which can be also the solution for the cases when you need to do urgent rollback, because there you have a button, just roll back to the previous version. FluxCD basically works same but different. It also runs, it can be executed in the same cluster or in another cluster in the separated namespace. Flux guys, they wrote their own Terraform provider, which means that you could install Flux with Terraform, which I find to be super sexy, because usually if you're sitting in the clouds, you use Terraform for everything, to basically create your cluster, and then you switch to working with the cluster. And in this case, with Terraform, you can create a cluster, inject FluxCD inside the cluster, and after that, you are ready for GitOps. FluxCD comes with so-called toolkit components, which are like controllers and custom resource definitions, which allow you to use Helm customized things. So it means that you do not need to create if your application already uses Helm or Customize, it's super easy to switch to Flux because it supports them as a first-class citizens. And also the good thing about Flux that it can commit changes to the Git repository and create pull requests. So as I said before, automation is the thing. So you want to merge to master, and then voila, the thing that you merge to master is running on production. However, on practice, sometimes you would like to have an eye on this. And what Flux can do, it can basically pull it can see that there is a new version of your Docker image, but before it will basically update your running application in the cluster, it can check out your infrastructure code where you describe your application and simply update the version of your Docker image there and propose a pull request with this update. And then somebody from your team can accept this pull request, for example, and then Flux will basically apply changes. Here, I just wanted to make a short overview of ArgoCD and Flux. We have much more deeper experience with it. And I'm really looking forward to the 29th of October when we have a dedicated talk about ArgoCD and Flux, some kind of like what is better for this use case, what is better for that use case, what are pros and cons. And yeah, I'm looking forward if you join us on this talk on the 29th of October, and the like official announcement is to come. I think on this part, I will finish up. So this is basically everything I wanted to share about why Kubernetes and why GitOps are big things at the moment. And I will give microphone back to Victor. Thanks for your attention.
Thanks, Alex. I think this was a pretty nice teaser for the next month. GitOps and ArgoCD and Flux are really, really cool tools. Like I use them personally also, and we have a lot of experience and a lot also of discussion with Alex, and also in the chat there was asking about bootstrapping, and all these topics we will handle the next time. But this time I wanted to talk a little bit more also about what do I need for my microservice. So because, for example, you have now a Grafana deployment, and you have your service, and you're like, cool, now I would like to have it somewhere deployed in my infrastructure. Maybe I've already ArgoCD with GitOps, and so I just commit and push, and it goes to my cluster. But you need a little bit more around that. So, for example, here are some points which you most probably will need. So you need some kind of routing. So it's available under, for example, Grafana EATS.tech. You need certificate management for Grafana. How do you do that? How do you inject secrets? Because you have some secrets. For example, you make a single sign-on with Keycloak or something like that. Then you need to inject some secrets. How do I handle that? And also, how do I make the binding from the DNS, so that Grafana ETS tech goes to my load balancer IP. And yeah, most probably you encountered also this problem. Then you have an image pullback off because you have the Docker rate limit exceeded. So yeah, and the last question which I want to talk with you is, do I really need to service mesh, and when do I need to service mesh? Yeah, this is a very personalized view about things, so it's not written in stone. It's just something which we experience in the IATS, and so especially what I experience, and I want to give you a little bit of yeah, my wisdom about the things and my point of view. So if somebody of you sees this others is totally okay. So yeah, now we come to the routing. So you want to expose it under slash, and how do you do that? So you have multiple ways to do that. So either you take the default Open Telecom Cloud Load Balancer, but with the ingress, but it works just for minimal setup. So if you have some very easy stuff to do, you just need to expose it and don't need to have some middleware or set some custom headers or something like that, HTTP headers. Then this approach works for you. But most oftenly, you need to have more complex routing, and that's why you will either switch to Traffic or Nginx. These are the most two famous one. Traffic offers you more flexibility because you have such a Kubernetes resource definition, custom file, which you can put into your microservice Helm chart, and then it defines the routing for this microservice for you. This is a very good thing because then you don't have a centralized global configuration, and the routing itself is very near to the service itself. And this is a very, very good approach. If you have some high performance setup, so you need to have some gigabytes per second or something like that, then Nginx is your friend because you can highly configure Nginx. So we use both. We have some project where we need really to have high bandwidth and a lot of traffic through the pipelines, and there we use Nginx. But most of the cases we use Traffic because in the microservice world is, in my opinion, the better solution for that. Easier to understand and also easier to handle. So I will focus now on the traffic routing. How does it look like? This, for example, is the ingress route. I said I wanted to expose Grafana. So I have here this YAML definition, I put it inside my Helm chart, and it shows here that I have here my name Grafana. It has 2 entry points, so web secure is HTTPS, web is HTTP, so port 80. And then I say here, it draws the following. I have this rule, so such a host regex, so Grafana ETS.tech needs to be the domain, the host, and the path prefix needs to be /. So yeah, and what I'm doing then, I make also a middleware. So I have HTTPS redirect. So basically, if you're coming from the web port, then it will automatically redirect you to HTTPS. And what kind of services will he route to? This is my service Grafana. Then you have to expose this service under the namespace default. And this one is available on port 18. And also I use TLS. So I have here my certificate, which I use. Very easy to use. Our approach in ETS is to make things as simple as possible, so that even like Kotlin developer or front-end developer can understand our DevOps code and are able even to define their microservice by themselves, because this is like the very cool dream of the DevOps guys. So basically the developers making themselves just a pull request for their microservices, and you just need to look, okay, everything is okay, accept the pull request, and the services are online directly on your development QA stage and prod stage. So how do we do the certificate management? Yeah, this is very easy. Cert Manager, it's easy to use, and in my opinion, there's no right alternative for that. So basically, it connects with Let's Encrypt and makes you automatically some certificates for your domain. It looks like that. So you have here your certificate. This is also again for the Grafana. So you type here common name Grafana ETS tech. Below there the Grafana ETS tech, and then he issues for you the certificate and renews it also automatically. Secret management. So what do we have for secret management? As you maybe followed our other talks, we are a big fan of HashiCorp Vault system because if you take security seriously, then it's a very, very good approach. There's also a dedicated talk about that. You can look also in the community about Terraform, how to bootstrap Vault. And it offers you a limited live token. So you log in over CLI or over UI, then you get your lifetime token. And it has also very good integration with Terraform Kubernetes. The only downside is it's a little bit complex to bootstrap it. So the first time set up servers with HashiCorp Vault is a little bit complicated. But we talked about that in the previous talk already, so let's skip that part. How can I inject my secrets into my application or my Helm chart? So for example, I have here my Grafana secret. So the secret path is secret/data/Grafana. So it's here. And the secret key is password, and the secret key value is then 1, 2, 3, 4, for example. Normally we would take seriously password, but this is just a demo case. So now I want to inject, for example, this secret inside my Helm chart. How can I do that? Either you take like the standard approach with the Vault agent injector. So inside your Helm chart and the deployment, you're then just giving this annotation. So you say here, like Vault agent injects is true. And here, this is a specific line just for this one secret. So you say here agent inject secret, and in the end here in this part, you say then secret data Grafana. This is exactly the path which we defined before in the last slide. So, but then he just creates a file there and puts the secret inside there, but it doesn't expose it as environment variable. And if you want to customize it a little bit, so you make it export or something like that, then it becomes a little bit tricky with the Vault agent injector. That's why there's sometimes also custom solution. And for example, for ArgoCD, there exists a specific plugin which will help you to inject the secrets. So just for example, if you, for example, use ArgoCD, then you can use a normal secret or like Kubernetes secret, and then you just give here the path. So in that case, it would be secret/data/Grafana. And here as a data password, here just giving the key itself. So it would be here just password, but base 64 encoded. Then you put it here, and then after it boots up, and then it decrypts it, and then it gets injected into your container. So there's a lot of ways to do that. I think this approach is very good. And if you want to have the more secure approach, then I would go with the Vault Agent Injector, because then you can create a file, source this file in your process, and delete after that the file again. Yeah. Okay, now we have secrets, we have the routing, we have a certificate, and what's still missing is the DNS management. So I have my load balancer, I have my public IP, which is 8020, and now I want to bind it to Grafana EATS.tech. So how can I do that? So if I have everything optimized, I have my Terraform pipeline, it creates me everything. Maybe I have also Flux or ArgoCD installed with Terraform. It bootstraps me all the Kubernetes stuff, so I'm ready to go. But then this one part is missing, yeah? So I cannot just press Terraform, apply, and then go to Grafana EATS.tech and it shows there. So I need somehow to bind this public IP then to my DNS provider. And how can I do that? So you can just do it manually. So you boot up everything, Kubernetes, all services ready. You have the public IP, take this, copy this public IP, and then go to your DNS provider and enter there. Yeah, but that's not a good approach. So what you can do also, you can do it with Terraform. Terraform has also a solution for that. So you can configure your DNS provider over Terraform. Yeah, but since we're using Kubernetes and we want to keep that very close to ourselves itself, and it should also configure and be able to build it up by yourself. So basically, the developer, when he makes this microservice, he should also develop then everything what he needs to access your microservice. And if we do that approach, he needs to go to the Terraform project, and then after that, he needs to go also to where the microservice is defined in the Helm chart. So this is also not a good approach. The only like viable solution or like choice to using that here is if you have some virtual machines and if you have everything inside Terraform. So if you define everything inside Terraform and don't use Kubernetes, then you can also do it with Terraform. But the best solution is, in my opinion, to use external DNS. External DNS for Kubernetes is a pretty cool service which you can deploy inside your cluster. You deploy your external DNS controller inside your cluster, and then you need to define a specific YAML file where you define that Grafana EATS.tech is available under 80.20 blah blah blah, and it picks up automatically this file and adds this entry to your either OTC domain name service or some other. You can put it wherever you want and configure it there. Then. So it will automatically update it, and you can also delete it automatically. So you can fully configure through your Kubernetes cluster all your DNS entries. And I think this is pretty cool, because when a public IP just changes, it will just automatically update it inside the domain name service. How does it look like? So as I told you, you need an external DNS controller, and this is the configuration for OTC for the external DNS controller. So the most important thing is here the provider designate. You need to tell it to the Helm chart, and also this configuration here. This part is the important one. Here, this is I copied all from one of our projects. So you just need to create a specific user inside the OTC EDM system. I called it this time DNS manager. The password I auto-injected via Vault. Here the auth URL is every time the same. And here's my region, my domain name, and also my project name. So it's pretty cool, and after that it runs and works smoothly. And yeah, so after I configured the controller, I need to have the specific file for our Grafana Helm chart deployment. So here I defined this, so it's very easy. So you see here my public IP address, and here's the DNS name. So because it's a Grafana Helm chart, so the release name will later be Grafana. So Grafana test tech. I want to have a record, and this is my public IP. Very straightforward, very easy to use. If fully documentation how to set it up will come, because I'm currently writing a community article about that, how to set it up on OTC. So you will not have any problems anymore with the DNS management. So there will be fully article how to set it up inside CCE and how to connect it to the OTC domain name service. Just take a look at the community. So this is the final picture. So we have secret management, we have DNS management, we have our ingress route, we have our deployment and service from Grafana. We have also a certificate. So we are ready to go. And now we are hyped and say, yeah, okay, our microservice can run. Connect it to a GitOps tool, for example, ArgoCD or Flux, and say, yes, now to run. And then Docker pull rate limit. Image pullback off. Yeah, your container doesn't start. Yeah, nice, super. So what's happening? So I think mostly of you guys also encountered the problem. So I have my Grafana deployment deployed everything. I'm super happy everything will run. Then it tries to pull this Docker image, Grafana/Grafana, and this version number from Docker Hub. And Docker Hub says, no, you have pull rate limit exceeded. You pull too often from Docker Hub and you're not a registered user. Yeah. Super. And how to solve that problem in an elegant way? There is a project from, I don't know his name, Alex, most probably. He developed the tool Registry Creds, and basically he makes a hook. So every time when you try to deploy some services, then he hooks into the current deployment and puts this image pull secrets there. So basically upfront create a Docker secret, and then he references directly to this image pull secret. That's does for you. So it's like 2 minutes of work, and you don't need to care any more about image pull secrets, because otherwise, if you don't use such a service, you need to go to every of your Helm chart, and everywhere you need to add image pull secrets. And that's a lot of work. And maybe you forgot 1 or 2 services, and then you deploy them new, and after 2 months, you encounter the problem with it again, and there stands image pullback off. So yeah, to solve this problem, just use the service. Or there's also other approaches. The better way to solve it is through Harbor, because what we did, we deployed in every our cluster with the Harbor system, which works as a security gateway. And we have a special Helm chart for that, which enforces your whole clusters to go to this Harbor proxy. And I just put inside this Harbor Helm chart, I put my Docker secrets, and then he checks all the images about security issues and also works as a pull-through cache. Yeah, but I will not go into detail, because I think I will either make a dedicated talk for that, or I will make a community article about that. But if you have some questions about that, and if you need urgently, you can just contact me, and then we talk about that. So let's talk as the last point about service mesh, because we edited the pull secrets and yeah, deployed everything. Our service is running, everything is cool, nice. And now it's the question in the microservice world: do I need service mesh or not? So 2 popular options currently is Linkerd or Istio. The Istio stack consists mainly of Jaeger Envoy proxy and Istio itself. So Jaeger is for cloud tracing, so you can see who communicates with whom, and how is the status codes, do the requests go through, how much bandwidth is used, and stuff like that. So it's very good for tracing. And the Envoy proxy makes some rules, like are you allowed to call this API or not? So how does it look like? This is, for example, the Kiali dashboard, which shows the interaction between the services. And you can see here also on the right side that here's the traffic, and then it shows how much success rate is there, and if everything works well. So you can filter also here. Yeah, why and when would you use Istio? One thing is Istio adds complexity. It adds complexity to your cluster because he puts on every pod, it puts like a proxy up front. So you will encounter a little bit of performance issues. So like performance, it needs a little bit more of CPU and RAM power, but also it adds more complexity to your whole system. So you should really think carefully if you want to have that or not. And most of the cases, you probably don't need it, except when you're building some huge clusters. And yeah, and also if you need some egress rules, because in my understanding, in my knowledge, currently there's not the possibility to define an egress rule inside OTC CCE, but Istio solves this problem for you. So with that, you can define egress and ingress rules, and then you can define much more the security and keep, for example, a namespace completely separated from other namespaces. And this is pretty cool, but really depends on your kind of setup. And most of the cases you don't need that. So the last point for today, I wanted to give you some buzzwords to maybe look into it, things to keep an eye on. A very interesting topic is function as a service. For example, OpenFaaS solution. We tried to, or we implemented also OpenFaaS in the OTC and CCE, and it was running also. So there you can run, for example, Kotlin code as a service, as a function service. Then just something to read. Kong is an API gateway which solves issues for you. For example, if you want /Grafana, you want to block it, just block every user out except these ones which have the Grafana role inside your EDM system. So this is something where Kong will help you as an API gateway. Rundeck and Stackstorm are very, very cool automation engine, which you can, when you have like GitOps and you want to set one on top, for example, you want to control your deployments over Alexa or over ChatOps. So basically you can write in Slack just, deploy me to QA or something like that, this version. So there's where Rundeck and Stackstorm come in, and they can help you very good with that. Home Policy Agent is also policy-based control for cloud-native environments. It enriches your cluster a lot with security and helps you to define these accesses for example, like some image repository cannot be pulled inside your cluster. You want to forbid it, then you can do that also with Open Policy Agent. And also a thing to look out is HashiCorp Boundary. It's the next level single sign-on system. I tested it half year ago, something like that. Then it was not working super smooth and was not, for our current case, not the solution. But it's a very interesting project, and it's very important also keep looking at it and to see what they will do next. So that's from my side. Thank you very much for listening.
First of all, thanks you, Alex. Thank you, Victor, for this really exciting webinar. It is always a pleasure to have you here in the community and see what is possible using the OTC in combination with the CCE, and see what you can do with all this DevOps and GitOps principle. It's really impressive. You even mentioned that you will post some blogs in the community portal, and so I would remind you, you should also have a look during the next week in the community portal. And Stefan, now back to you.
Not a lot to add after your moderation here already, Uli. So also from my end, thank you a lot to Alex, thank you a lot to Victor, and see you again. Bye.
Bye-bye.